Hey, for lesson 3.2, we're going to solve more complicated exponential equations. Yesterday, you solved some pretty simple ones where you just had to rewrite both sides of the equation as a power of the same base, and then you could set the powers equal to each other. This is going to be a little more involved. We're going to start with looking at some quadratic forms. So we're going to use a substitution technique like we did before that y'all love so much, and we're going to do this with exponential equations. So let's take a look. We're going to solve exponential equations of the form a to the 2x plus b, some number b times a to the x plus c. So an example of this would be something like, say, 3 to the 2x plus 4 times 3 to the x minus 5 equals 0. This is what we call a quadratic form because we can make a simple substitution like y'all loved so much the other day. If I let u equal 3 to the x, then u squared is equal to 3 to the x squared, which is equal to 3 to the 2x because of properties of exponents. And I can then make a substitution where I have u squared plus 4 times u minus 5 equals 0. And we're back in a quadratic equation. And you know we can factor this to u plus 5 times u minus 1, which means that u has to equal negative 5 or u equals 1. But recall that u is 3 raised to the x power. Now think about this. Can we raise the positive number 3 to any power and get negative 5? And that's impossible. You can't raise 3 to a real number power and get negative 5. If you raise 3 to a negative power, it becomes 1 over 3 to that positive power, which is a positive number because 3 raised to any power is a positive number. If you raise it to the 0 power, you get 1. Hey, there's going to be the solution here. But you can't raise, if you raise 3 to a positive power, you get a positive number. So we can't have, this is what's called an extraneous solution. If it was possible, it would solve the equation, but it's not possible in the real numbers. So this is referred to as an extraneous solution. And this one, if we raise 3 to the 0 power equals 1, which is 3 to the x, that means, x equals 0. Let's try one more. Let's do 5 to the 2x minus 8 times 5 to the x plus 12 equals 0. So in this case, we'll let u equal 5 to the x so that u squared is equal 5 to the 2x. We'll make our substitution. U squared minus 8u plus 12 equals 0. And we'll factor that to u minus 6 times u minus 2 equals 0, so that u equals 6 or u equals 2. Now that means 3 to the x equals 6 or 3 to the x equals 2. And while you don't know numbers that are going to make that true today, you will find that we will later on this week or next week, we will learn how to solve those equations for x. But in the problems you see today, you will most likely only be asked to, let's see if we have one like that. There's one, we'll do those in a minute. Oh, they're all like that in the pretest. But what you'll see is, I think they'll say, which of the following equations must be true? If it's not something like 1 or something that you can very easily see, it will be something like this where you'll have to figure out which of these equations would have to be true. So in this case, I might have the answer choices as, let's say, A equals 6, or sorry, A is 6 to the x equals 12, or B is 3 to the x equals 6. Let's see, would be 5 to the x equals 96, or D, or something. There would be equations like that. And you would know after you solve the equation, after you got reduced to this part, that that would be the answer. And that's how we'll do these kind of problems in 3.2. Next video, we'll do those other kinds you saw in the pretest.